All right. So welcome everyone to the 32nd working group meeting by Interoperable Characters Avatars working group. And this is our very first SDO roundtable. So we are so excited to host this. All right. So since Yannick also mentioned about the agenda, so I'll be going over that right now. So the flow of the agenda will go as follows. So we'll talk about few starter information to guide the speakers with timekeeping and also to for other attendees like to talk about who are all the participating as SDOs in this roundtable. And then each SDO representative will get 14 minutes, and we will be going in alphabetical order. First, it will be AOUSD, and then IEEE, and then Khronos, MPEG, VRMC, and then Web3DC. And the gist of the agenda that we have outlined here is, this is something that we have requested each SDO, which is to cover the background on SDO, like what is their origin information, location, and key contribution, and what are the current standard initiatives and roadmaps that they are currently executing, including key initiatives, use case support, open source model, or they have a different type of model. What are their future roadmap and priorities? What are some key challenges they are having? What are some collaboration opportunities they are looking for? And how the working group can help them, right? So this is like a high level agenda that we shared them. But again, each SDO has a freedom to decide like how they want to present this information. So they may not stick to this format completely. So, they do have the freedom to pick and choose, what they want to present in that 14-minute timeline. And towards the end, we do have 27 minutes Q&A. If some SDO representative finishes their session earlier than 14 minutes, then we will have more time in the Q&A section. On the timekeeping front, we'll be using the Zoom's time feature. And Hiroki Eguchi here will be the timekeeper. So every SDO will get 14 minutes, and you will get a voice notification exactly at 2 minutes and then 1 minute so that you can start wrapping up your meeting. And then the timer is displayed on the top right. So even when you're presenting, you'll be able to see the timer running. So please watch out for that and plan your content accordingly. And these are the participating SDOs representatives. So we have Nick Porcino, Katy, Schildmeyer, Ken, Jakubzak, Quentin, Avril, Hiroki, Omae, Jody Williams. And we will start with AOUSD, where we now have Nick Porcino, who's a principal engineer at Pixar, who will be starting off with the first SDO presentation. Nick, feel free to share your screen and start your presentation.
So by way of introduction, I'm Nick Porcino, as you just heard. I work at Pixar. And just like very, very briefly, for those of you who haven't met me, I made my first company more than 40 years ago. This is working on interactive characters in the forms of small robots that eventually became video games and small dangly toys at Bandai in Japan. I worked on video games and movies over the years with an emphasis on real-time interactivity. I spent a number of years at Apple where I helped launch the open source initiative with Pixar for USD. And this is me with a very early headset prototype that I helped with. Spent a little time at Oculus and helped launch Quest as well. Finally ended up at Pixar, and there's a picture of the USD team and management receiving an Academy Award last year for OpenUSD. So very quickly, I'm sure you're all familiar, but I just have some slides to share to set a stage. Here's an early film using OpenUSD. And the fun thing is that USD isn't like FBX or OBJ or other file formats like GLTF. And when we're looking at this image, every single object here is like a single FBX file, but it represents a layer in a massive scene with millions of objects that are referenced. And the background that you can see there opens up in an IDE or USD view and is interactive. It's very, very high performance. USD files can compose hundreds and thousands and even millions of layers. The antique store in the middle of the shot here with Toy Story 4 has just about every asset from the digital Batlock that there ever was. So and there's something on the order of 1 million trees and 1 billion leaves in the scene. USD is used in a lot of different industries and in a lot of surprising places. Just as one example, the German train system has been modeled, and the trains show up as USD payloads and can move around and be simulated. It's used in factories, and this just shows USD in a prototype factory, illustrating various workflows. And just to come back to a minute about the point that USD isn't just like a regular scene graph where you have like a hierarchy of things, as is illustrated here in the referencing and instancing variety that I'm sure you're all familiar with. USD has another very interesting superpower that really distinguishes it from other scene graphs, and that is that when you're working in production, your different departments are producing thousands and hundreds of thousands of elements, and they need to be filtered and organized into a scene. And so USD has this idea of composition by layering, which means that you can organize all the shots and our things and bits in your scenes and shots hierarchically in a network and layer of opinions. And so what that lets you do is you can filter the scene for the bits that you want to look at. And also you can put opinions in the scene. So here I've added Alice and Bob in the middle of the composition. And if we decide that we want to change the priority of the opinions of the folks, all we have to do is swap the ordering in the layer stack, and the scene will now compose with preferences to Alice's choices. So that aspect of sublayering makes it very distinct from traditional scene graph, and that's kind of where the superpower is, and that's what's led to the ability to adopt it in so many interesting other industries beyond filmmaking. And just back to my original slide where I showed all the things that I've worked on, like my interest is in interactivity and characters and things like that. And so key focus for us and for myself in particular is how does USD work in that environment? And I'll get to that after introducing AOUSD. Here's the obligatory slide showing that USD's got quite a large infrastructure and ecosystem around it right now with, I think, pretty much universal adoption by most DCCs. So on to AOUSD. AOUSD is an open nonprofit organization that promotes 3D content and interoperability through OpenUSD. So AOUSD was formed, I'm not sure how long ago. It feels like a really long time. It's probably 2 years ago, I guess, a year ago, with these founding partners, Pixar, Adobe, Apple, Autodesk, and NVIDIA. Each one of these companies, starting with Pixar, has now got many years of significant investment and development into USD and has contributed major features to USD and is involved in the ongoing maintenance, development, exploration of its capabilities. And these founding members started the whole thing up. And now there's, an obligatory icon cloud showing that we've got quite a lot of partners and quite a lot of industries all working together with the organization on the mission. So AOSD is part of the Joint Development Foundation, which is a Linux Foundation org that is involved in a ton of different projects. And here's AOUSD with some of the sister projects, more than one of which I'm sure you've heard of and possibly used. Already mentioned, it's part of the Linux Foundation. So that infrastructure gives us legal and organizational infrastructure, lots of expertise around open standards and specification development. It's been a very, very interesting process for us to get involved with this, as we get people from different disciplines that we haven't necessarily previously worked with before who tell us how to word things for ISO and do all those kinds of procedural activities that yield a standard. So the main mission of AOUSD is standardization, specifically getting a written specification that is going to be sufficient enough that given the specification, you should be able to independently able to redevelop any of the technology yourself. In addition, it'll provide canonical documentation on how USD works, like exactly with every little nook and cranny explored and written down normatively. We're very far along the core specification work at this time. We're hoping to have first public draft later this year around SIGGRAPH time. And there's several groups in flight, each with a dozen or 2 dozen members from the different various member companies, all contributing actively to get this done. And it's been quite a very busy and interesting process, and is yielding results quickly. And we have liaison agreements with Khronos, the Metaverse Standards Forum in particular, so that we can attend each other's meetings and um, share our secrets and our plans. Same with the Academy Software Foundation and Building Smart. These are the ones that I've been in meetings with, so I'm mentioning them specifically. Um, so we are involved in all kinds of activities beyond beyond the specification. We do reference implementation of various algorithms. There's documentation in order to explain things that work out that we feel needs more coverage and exposure for people to deal with. And we're looking at setting up cross-platform, cross-domain, cross-company continuous integration and testing infrastructure in order that the members of the AOUSD collectively can all help to keep that going and distribute the load and the workflow. And so in terms of growth, we're looking for finding new opportunities for collaboration, adoption, and use cases. We're also interested in activities that improve quality of life for developers and users. And that includes documentation, suggestions on how to suggestions on how to set up and use the system, and so on and so forth. And we also have a number of interest groups. Advanced geometry, which is looking forward beyond the things that are in OpenUSD already, like that would include things like Gaussian splats, for example, in the future. AECO has an interest group, which means like people who build things like buildings. There's interactivity and animation not started yet, but should start soon and of interest to this group, no doubt. So I listed it here in order to see if anybody would like to come over and help us with those sorts of things. So here, I just want to wrap up by listing what I see as opportunities for your group and ours, which are to point out that USD already, of course, because we're Pixar and we have characters, has lots of support for characters. And the USD scale formulation in particular is a lot in common with GLTF skinning and VRM. And here I've just got USD view up with, a typical character that we distribute as part of our sample suite. But there's lots of differences. For example, we've got here a whole bunch of Material X materials in OpenPBR, which is what drives our look. It's a photorealistic, energy-conserving look. And down there, I've got a demonstration of like the MToon shader. And the MToon shader is not photorealistic. It's not energy conserve. And so there's a little bit of gap in how materials are transported through the system. So there's an opportunity to figure out there, like if we want to carry MToon canonically, how would that look? There's other differences, and here I'm pointing out that VRM has got a number of interesting specialties and specializations. For example, Spring Bones has a canonical skeleton that maps onto a more arbitrary skeleton in GLTF. I'm showing here also an animation blend graph.
Committed.
Thank you. We all rely on animation blend graphs in real time in order to move our characters around the screen and interact with them in interesting ways. And then here I'm pointing out with Wade there that we have very unique rigging at Pixar for our characters, and that kind of character rigging isn't easily representable in most systems outside of Pixar. And so there's a lot of exploration required to figure out, can these things be bridged? Should they be bridged? How can they be bridged? And in particular, I'm especially interested in our context today, in these things: interoperability across materials, standardized avatar rigs, standardized avatar metadata, unique concepts like spring bones,
1 minute.
animation blend trees, and interactive behaviors. And there we go. I don't have anything to fill the last 42 seconds. Thank you very much.
Yeah, great session. Thank you very much, Nick Porcino. Maybe a good time to give a virtual cheers to Nick for an incredible talk, sharing a lot of insights today. Yeah, we will. If anyone has questions, please make a note of it. You will have an opportunity to ask in the Q&A. So now we will quickly go to the next speaker. So next we will have IEEE standards essay, and it will be by Katy Schildmeyer, who's a researcher at IEEE SA P3141 Design Cycle Solutions. Katy, please share your screen and get started.
But I'm presenting on behalf of P3141 3D body processing. I am the use case researcher and coordinator. So I work with a group of people to see if a humanoid can move through different ecosystems and really take on different methods of approach within the 3D life cycle. So we also started in 2017, and we work with a series of different organizations. Of course, other standards organizations include ISO, ASTM. We've done projects with X3D, so the Web3D Consortium with Don, Khronos, seemly 2D, because we also work in the 2D relationship to 3D, 4D, and hopefully into 5D. And then the OCAC, which is an Open Circle Apparel Coalition relating to new research in the area of waste management. So for us, we focus in primarily on two categories, which is the humanoid and the coveroid. So a humanoid would be any human capture between a digital twin to a fictitious character in both the flat 2D animation all the way to 4D animation, and then coveroids, which deal with anything that is attaching to the human or that will eventually be attached to a human. So for the most part, that's apparel and soft good wearables in the biomed division. And of course, we draw that back to really, does it work with the digital twin, and does it work with the digital clone? So our initiatives are, what is the use case? And these are just some examples of use cases that we've analyzed and covered, and then drawn down every matching set of standard information so that we could create a 3D body processing standard on ways to capture the body or create the data that would go into a art character or into animation. So these are just some examples. So we've done mesh testing where we see how the changing of mesh may impact the logic of measuring a person. And this is very important for apparel design, especially when you're dealing with some measurements in apparel design that deal with 1/8 of an inch or 3 millimeters or less. So for us in apparel, which is my key background, it's very important. And then we get into how do we test those items within the coveroid range. So we have a picture or a set of images where we've tested different body rig structures in relation to a stable pattern, and how that changes when different programs say they all carry the same body measurement. So that's just one of the examples that we cover. We also have, again, the focus on use case initiative, and some of the key areas that we really outline as being a very important aspect to the standard is our measuring units native, and having a display within those systems, axes and gimbals that are also native to the capture and build of the person, file capabilities and completeness of the file capabilities. So we've tested different file capabilities with very extensive file formats, and try to find where lostness occurs. Metadata records, again, relating back to both human and coveroid. And then the bridging of relationships between those systems also gets a standard. And then, of course, how easy is the interoperability chain going from, let's say, body capture for production purposes and pushing that same body capture all the way through into a marketing and art purpose-driven capture. So those are very different needs, and they have very different variables to them. And basically, we're bridging the gaps between all of those. This is, and this is one of those challenges. So we find that a lot of users within different programs want to use the reface technologies or utilize AI without a person's permission. So we really talk about the PII of a body scan, the PII of, in particularly, children being utilized within the body capture arena, and why that's important. So we have, I would say, considerable information related to the metadata requirements, the normative aspects of what you can put into the PII, and of course, how that relates to an EULA. And one of our other challenges, as Don would concur, was access information. So we've basically gone through all of these programs, figured out, what their native access information is, and how that can help us create more interoperability between the interchange systems and the file handling. This is a big issue, especially when you start getting into upskilling an entire industry, and fashion is one of those industries where the designers are all having to be upskilled and they don't understand any of this environment. So this has been a huge challenge actually for that industry within itself, as well as its handoff to robotics within sewing. So that we see will be a challenge going forward with technical pattern information in relation to sewing. So ways to help. We have metadata examples that we utilize that we found are common through every system for both the humanoid and the coveroid. But again, we're always willing to accept more people on that have a different perspective and want to add richness to the criteria of what would be a standard set of metadata examples for humanoids and coveroids that we can build into GitHub or into a different repository, or again, into an IEEE standard of just metadata for these specific items. And this is an example that we find is very common within apparel, but if we're working with a garment specifically in, let's say, Ready Player One, they're not going to carry a certain level of information. But it's important to keep definitions and naming conventions very clear from inception to top of production and into the art sphere. So again, if I'm taking a coveroid and I'm moving it from its inception for production, and I need to put it also into, let's say, a movie film archive for my brand. So let's say a costume design animator could go and check it out of our system or buy it out of our system to apply it as a costume in a film, then I would want to keep all that information there. And then, of course, if I wanted to make a twin of the garment and sell it online, or they get the garment from Commerce, the real garment, and they have a QR code that they can scan that would link it back to its digital replica, then the naming conventions really need to stay the same. And we're seeing that that's very disconnected. And a lot of the people generally naming clothing within the art forums, gaming forums, or otherwise don't actually have the definition related to what the garment actually is. So that's going to be very, very important as garments go from reality into art and gaming, and of course beyond. So this particular shirt, we would call it just a rolled sleeve denim blouse. And then it's got to carry all of this other information on the inside of it, especially if you're swapping different parts of the garment. And this is also important for something we have in our industry called the digital product passport, where every part of the digital information related to its production will be recorded and linked to a QR code or an RFID code, or even the blockchain. And this information allows us to track what's being sold, what's being exported, imported, as well as what its relationship to any other online product that's related to that would be. So for us, it becomes very important to have our metadata correct, as it will also relate back into the metaverse. And so these are just examples of other pieces of apparel where you have to then start looking a little bit deeper and beyond into what parts go into that garment and what makes it. And then also we have a garment on a form, so that begins a relationship with fit, and that becomes another part of the metadata environment that we, of course, always need help with.
1 minute.
And the big challenge that we are seeing is that we need more help with relationship to how many vertices can a file format handle related to a joint. So one test we did was with X3D, which is this little old guy right here, Gramps. He's not fleshed out like our other figures are. We actually had to do a lot of removal of the mesh systems and a lot of re-rigging to that system to allow us to bring our higher fidelity, higher mesh count grandpa into their system. And all that stripping away also stripped away some of the fidelity and shape, of course, of what that person really was, and then what that system needed. So that's just an example that you can click on and see if at a later time. And then, of course, right here we have a avatar that we've basically developed for the apparel industry. It has a lot of agnostic tools within it that allow us to do some fit testing. But this one may share up to 8 joints per 1 vertice. So it has to be able to hold more information to allow us to do more digital testing to then create less waste in our industry. And then, of course, the standard SMPL models work great for most everything else. And we just need more standardized information and file format relationships that can tell us what specific file formats do better than others. So that's kind of where we're at right now. And if you want to get in touch with us, Carol McDonald is our department chair. And of course, all of our standards information are listed here. And that's all I've got.
All right. Thank you very much, Katy, for sharing the work from your group. And I think it's a great time to give a virtual cheers to Katy. And yeah, again, for the questions, please make note, and we'll use the last Q&A minutes to ask those questions. We will now transition to the next speaker. So next will be Khronos Group by Ken Jakubzak, who's a software engineer at Meta. So a quick profile background on Ken. Ken, feel free to share your presentation and start with your introduction.
Okay, will do. Hi, everyone. It's a pleasure to be here. My name is Ken Jakubzak, and today I'm representing Khronos in their efforts to establish core avatar extensions in GLTF. A little bit about me. I've been working in AR/VR for the last 8 years, both as an engineer and a designer. My primary focus has been on presence and representation options. I currently work at Meta as a software engineer on their avatar platform team, and prior to that, I was at Microsoft. But let's talk about Khronos. Khronos is a nonprofit organization, and the standards we create are open and royalty-free for the industry to use. We've been developing standards for over 20 years, and we've continued to grow. We have over 160 member organizations, which range from large corporations to small startups, academic institutions, and individuals. Many of the standards formed through Khronos power 3D experiences, XR, AI, and parallel compute. We're member-driven, open to any company, and you might be familiar with some of the standards that have been developed through Khronos, such as OpenXR, Vulkan, WebGL, and GLTF. GLTF is why we're here today, actually. GLTF is widely used across the industry as a transmission format. It's imported by a wide variety of apps and engines, including game and XR engines for both native and web, as well as being output from almost any 3D tool. It's present pretty much everywhere. And due to its use across the industry, we believe it makes sense to leverage and extend it for the purpose of avatars. With the proper foundational basis, we believe standards for how avatar data structure are formed can be built around it. I want to take a moment to talk about VRM, as we've been working with them on this effort. VRM is widely adopted across the industry and originates from the VTuber community in Japan. It's based on GLTF being a set of 6 GLTF extensions. I won't go into more detail, though, as I know that they're speaking later during this workshop. As of October of last year, Khronos and the VRM Consortium announced a collaboration where we've agreed to develop both GLTF and VRM as global open standards to support avatars in the future. Since then, we've been working to review their spec and prepare a set of recommended changes for this phased convergence. And in parallel, we're wondering how we can expand this initial mission to also provide a foundational set of avatar extensions to the industry overall, for a variety of use cases and markets. So what are our biggest challenges in this space? Understanding all of the use cases and requirements and gaining consensus on that is a pretty big task. The biggest hurdle, from my perspective, is that no one can truly agree on what constitutes an avatar. There's no one-size-fits-all approach due to the dynamic nature of representation. And most vendors and industry members have differing ideas of what best practices and implementations are. And because they're needed across multiple platforms and have different use cases and markets. It creates this large web of compatibility, quality, and performance requirements. To that point, think about avatars across the industry today, from social experiences to professional settings, commerce and education purposes. Each have their own requirements, some which overlap, but some that are completely unique to that scenario. And this makes industry standardization become somewhat complex when it tries to meet all of these needs at the same time. So keeping that in mind, we also have to talk about interoperability challenges. These occur at the intersection of data definition, hardware capabilities, and software implementation. That being said, from a GLTF perspective, thinking about the data portion of this and how it's fragmented both in what it's presented as to these endpoints and then how those endpoints interpret them is something that I think that we need to focus on and try to tackle. If you take a look at these examples, it's pretty obvious when you think about just rigging and animation differences, as well as like expression sets. Across the industry, you would be hard pressed to find one-to-one examples of rigs like from two different experiences. They're likely very different, both in the skeletal structure and the bone hierarchy, whether they have helper bones, etc. And the same can be said for expressions, regardless of whether it's driven by blend shape or joints. No two operations likely have the same exact set. Even if they're based on the same underlying research, like for example, facts, they may have differentiating sets due to personal preferences or internal implementations, which creates its own challenge when then trying to interpret it at endpoints. So if we take a look at this and we think about it just a little more, these are examples when you look down the line where there's a lack of standardizing how the data is then presented to these endpoints. And proprietary and platform-specific implementations make it even harder to enable those avatars to be transported from one platform to another. It's unrealistic, though, to expect any industry member or institution to adopt a single skeleton definition or a motive expression set. Our goal should be to enable vendors and partners to still use what they want while providing a common interface to define and/or remap that data while providing documentation on best practices, as well as referencing commonly used implementations. So to aid in solving this problem, we want to begin the conversation around data structure and standardization through GLTF extensions. To us, it feels as though we can't solve these challenges without some form of common language. So how do we overcome this with GLTF extensions? It's important to call out that we're still in the process of figuring out how this is going to shape up. We don't know exactly the form that our core set of avatar extensions will take. And we also want to call out that capturing all possible permutations of the challenges in the previous two slides would be very difficult to do. And even if we managed to do so for the current state of the industry, it would become outdated almost instantly. Not to mention that that design would potentially block us from easily adopting new functionalities in the future and providing them to the members in the community. We believe that we can overcome this inherent problem by creating a set of very targeted functional extensions. Each avatar extension becomes part of a set of Lego building blocks that assist in composing this whole, which is an avatar. Avatars, as a result, become self-describing due to this mix and match of functional extensions on them that describe the specific and specialized functionality required for them to function as expected. So if there's then degrading experiences or like platforms where they can't have all of those functionalities required, there's then a question of, oh, are they able to actually be used in those platforms? Or alternatively, is there a fallback? That's maybe getting ahead of myself, but it's something that we need to think about as we go forward with this. We believe that this route, though, will allow us to establish a core set of avatar extensions without potentially leaving out critical functionality that some vendors or SDOs deem vital to their operations, enabling a path then at that point for them to implement and work with us to bring that functionality to the community as a whole, as well as then share their their required data for a structure for their particular platforms. This also means that we can then assist with the much needed standardization of how data is presented to others across these platforms. Hopefully this would then begin that conversation and make it so that we can all agree on some form of standard. And then hopefully that would ladder up to assisting and making it easier to then translate these avatars in between platforms and experiences, which, if I remember correctly, is one of the main goals of this working group. So that then asks, hey, how can we all collaborate? I just want to call out again, this is a huge problem. It's too large for any one organization to tackle, and collaboration across the industry is going to be vital if we want to succeed at this. We'd love the MSF Interoperable Character and Avatars Working Group to work with us on confirming that this is valuable and working with us to do deeper exploration of the use cases and requirements. Facilitating interactions and roundtables like with Meta, Roblox, and Linden Labs. Continue to help coordinate between multiple standard organizations and standards like today's roundtable, for example. Providing reviews and feedback on our proposed extensions and other standards. Continuing your work in the open source translation framework for converting platform avatars and providing and facilitating interoperability testing assets and frameworks. Other SDOs, we'd love to hear you on what are you working on? Can we leverage your work and save effort while avoiding fragmenting the ecosystem? Can Khronos assist you? Can we help you through technical collaboration or joint visibility? We think that this is a space where collaboration is necessary, and we hope to hear more from you, and we hope to collaborate with you all in the future. Thank you all for the time. Thank you for listening to me, and I look forward to talking to you all in the future.
Thank you, Ken. Yeah, really good call outs on the interoperability challenges and collaborations. So thank you for initiating the conversation. So yeah, let's give a virtual cheer for Ken. All right. So next speaker on our list is from MPEG. It's Quentin Avril, who's a senior research scientist at InterDigital. So here is a quick profile of Quentin Avril along with this digital avatar. So Quentin, please feel free to share your screen and start your presentation.
Okay, thank you very much. Can you hear me well?
Yeah, we can hear you well.
Okay, cool. Yeah, thank you very much for this invitation. So special thanks to Zeno and Hiroki for the opportunity. I'm very pleased to be here and present the work. By the way, if this is a bit noisy around me, I am at the IEEE VR conference right now in France, in Saint-Malo. So I have it's a crowded place. I found a place to hide myself in a corner, but I apologize for the sound. So yeah, I'm Quentin Avril, senior scientist at InterDigital, and today I'm going to talk to you about the work we've been doing in MPEG, about the Avatar Representation Format, ARF. A quick introduction I wanted to do. So if you don't understand or if I am missing some details today about the work we've been doing in MPEG, here is a list of the former talks we provided within MSF. So from 2023 to the last talk was provided by Imed Wazizi from Qualcomm 2 weeks ago. So if you want to find some additional details, please check on the MSF YouTube channel or the MSF website, and you will find additional information. Yeah, as I was saying, I am at the IEEE VR conference right now, and on Saturday I participated to the first edition of the NGA workshop, next generation of Avatar, where I did the promotion of our work in MPEG Avatar. And I participated to the panel with a lot of great academic researchers. I was the only one doing research, in-serial research, to the future of Avatar research. You can find information online. And today I'm going to talk to you about MPEG. So I am not an expert about the MPEG group. I've been working in digital human for more than 15 years, but I've joined MPEG less than 3 years ago. So I'm not the expert. So basically, a quick introduction is that it's a 40 years old, almost 40 years old group in standards, working essentially on standardization of multimedia. So if you want a quick sample of well-known format that came out of MPEG, you have the PNG or JPEG for the image, MP4 for video compression, MP3 for audio compression. But they don't only do image, video, or audio. They also work in graphics like mesh compression, point cloud compression, light fields, and also systems like scene description and now Avatar. So inside MPEG, there is a specific branch, which is MPEG-I. The I stands for immersive. And this is all related to the file format of immersivity. So, and inside this branch, there is the SD group, the scene description group. And this group is at the border between two existing formats. So Nick presented at the very beginning the great format USD. So this is here on the left side. So this is the goal of this new SD project was to propose a new authoring interchange format. But compared to USD is a great format, but it's not compact. It's not, I would say, optimized for import process, for example. And this is what MPEG SD was looking for. So you might ask yourself, so GLTF would be a good candidate because on the right side, we wanted to have something real time, so with a transmission at runtime. So this is what GLTF is providing. But GLTF was not compatible with, at that time, I was not at the beginning of SD, but was not compatible with essentially with avatar, audio, haptic, AR, anchoring, or interactivity. So that's why this MPEG ISD group was born. It's to merge, I would say, the good advantages of USD and GLTF in one single file. So within MPEG ISD, the journey of Avatar started in 2022 with an exploratory experiment where we asked ourselves, should we have a specific placeholder for Avatar within MPEG ISD? And the answer came up in 2023 by saying yes, of course, and proposing some vendor extension in GLTF in the second amendment of MPEG ISD. As you can see here on the GLTF architecture, so now there is an MPEG Avatar proprietary property in the GLTF node, indicating to the system that this is the user representation node. We also proposed this year in 2023, we presented Morgan, so as the MPEG reference character. So I'm going to say a few words in a few slides about Morgan. And now, less than a year ago, we kicked off the MPEG avatar format, so which is now a new part. So this is part 39 of MPEG-I. So it's not only now in MPEG-SD, it has its own part. And so in July 2024, we kicked off this project, and we went through many technical contributions. We're still it's still work in progress, so there is still room for improvement until this summer or the next fall. And we hope that in Q1 2026, this first phase of the standard is going to be international standard. So as I said, this is phase one. Phase one is a CG-based representation, and phase two, which is going to start in Q2 2026, is going to be AI-based representation. But as Ken said previously, it's a really big challenge. So yeah, quickly on this one, just the use cases and devices that this MPEG ARF, MPEG avatar format was tackling. So of course, from smartphone, tracking your face for video calls, of course, VR, doing some training or whatever, AR, but also being tracked with your simple webcam on doing some video conference, but also for gaming and what we call the onset, so like TV shows, live concerts, anything that would require tracking a specific user. So this is all of the use cases that when we went through the requirements process of MPEG, this is all of the list of use cases we defined with many detailed examples. But basically how it works, this avatar representation and coding is that on one hand, or on the left here, you have this user tracked by any devices. And all of these devices are encoding the information, sending this information through the internet, and this is decoded on the other side. So it can be on another user equipment, it can be on a game server, it can be on any other device, and it renders the avatar. So basically, this is well known as the transmission chain. So as a acquisition, encoding, transmission, decoding, and display. And MPEG avatar representation format is tackling really the from the encoding to the decoding part. So we're not doing any acquisition format. We're not doing any rendering. We are really wondering what type of information do you transport? How do you transport? How often? What are the bit streams if you want to animate your avatar and all of these questions. So right now, what is the snapshot today in March 2025 about this ARF format? So ARF is composed of an ARF container. So here is an example with a zip container. So you can see there is this ARF file, which is a JSON-based format where you have the neutral face encoded in a GLTF binary format, so the GLB. And here is just a sample of 6 blend shapes, but we have many more, but and following the OpenXR naming convention. And the ARF document is really containing all of the detailed description of the components that you need for the base avatar model. So you have the structure with many LODs, for example, and each LOD has a different skeleton, skinny weights, meshes, but also nodes, which is the philosophy of GLTF, and then blend shape sets and landmark sets. Also, if you want to do some 2D or 3D landmarking animation, it's also compatible. I'm not going to deep dive into a lot of details, but if you want to check this ISO standard, it's accessible. And of course, animation streams. So a format for animating blend shapes and joints so far. This is what we worked on. And how do you transmit this information in a compressed or uncompressed way? And ARF supports multiple animation frameworks for body, face, hand, and soon this is going to be compatible with the gaze also. So Android XR, OpenXR, ARKit, all of these frameworks. It supports multiple level of details, as I said, and also offer a very interesting feature. And I think this is a big challenge for the future about privacy. So the partial access to the avatar. Partial access is really that you have your ARF avatar file and you don't want to share with all of the platforms all of the information that are in this file. So you may want to say, no, this is for an healthcare application. I agree to share, I don't know, my morphology, my weight, or whatever. But if I'm doing a social app, I don't want to share this information. So you have this partial access. And of course, you have all of these authentication features. So you can encrypt your data, you can authenticate with codes. And that's also something that is very, very important for the future. For the animation, so this is I would say, no rocket science here. It's pretty straightforward, but it's really aligned with what MPEG SD architecture is doing. So basically, you have your RF document here on the bottom, or RF file on the bottom left, which goes into this avatar pipeline. And it goes through an avatar decoder, which is decoding 2 types of information: the base avatar model, so what does it look like, and the formats that you're expected for the animation streams. And the animation streams are coming from the network, and they're first filtered by these blocks saying, okay, they're compatible. And then they're merged with the base avatar model to say, okay, now I can animate my avatar. And this is done in the avatar media function, and which are feeding buffers like vertices buffer, textures, and all of these, and sent to the presentation engine. So a game engine or any DCC tool that you want to display and render the avatar. So this is how it works. A few words about Morgan. So Morgan has been presented 2 years ago. So this is the MPEG original reference geometric avatar neutral. The name sounds a bit weird, but we found the name after the acronym, so that's why. It has 54 blend shapes based on the facts, 36 spatial controllers, and this is all of the features, technical features of Morgan. A very interesting feature of Morgan also is the semantics that you have on the vertices and faces. So I know this table is kind of unreadable, but the goal is really to show you that if you want to get specific access to, let's say, for example, the left arm, you can crop, so you can go on arm left. Here you can crop the vertices on that domain, and you're going to get the mesh is going to be completely cropped at the arm left. Same on the face. So these are enabled to attach semantics to the body. So if you retarget Morgan to any morphology, you're going to get the semantics retargeted. If you want to put some specific signals or triggers on the body, it really helps. And Morgan comes with, of course, a full skeleton made out of 68 joints. So as Nick said previously, or no, Ken said, we cannot all agree on the same skeleton, but at least we provided one. So if you think this is the good one to use, it's possible to use it. You have naming convention. Okay, I'm going to accelerate a bit. I just have 3 more slides. So yeah, we have reference software for ARF. The source code is available for MPEG members and on request. And we are working right now on demonstrating that to different standardization groups like 3GPP, MPEG, like the full end-to-end pipeline. Working on exporting tools also with Blender, Maya. We want also to show the interoperability with other formats like VRM, DNA from Epic. So quickly, some takeaways. So don't forget that MPEG is proposing a standard for avatars. So they support 39, phase 1 and phase 2. There is still some technical and informative contributions that are work in progress right now. Morgan is considered as the MPEG reference character and is also available. And of course, we want to work with everyone, so it should be considered by MSF and documented. So thank you all. Thank you again, Zeno and Hiroki, for this opportunity, and thank you all for the great talks. Thank you.
All right. Yeah. Thank you, Quentin. Yeah, a lot of new updates from the last time you presented. So thank you for that. Yeah, let's give a virtual cheers for Quentin. And I also see a question in the chat which we can answer at the end of our Q&A session. So the speakers can prep for it. All right. So next on our list, I'm gonna quickly share my screen, is the VRM Consortium. So the speaker we have is Hiroki Omae, who's the director at VRM Consortium. So here's a quick profile, Hiroki Omae. So Hiroki Omae, please feel free to share your screen and start the presentation.
Hi everyone, I'm Hiroki from VRM, and I have been working for Unity for 13 years, and now I'm an individual game developer, but continuing to support the VRM consortium as one of the director.
Yeah. So sorry to interrupt. Is it possible to maximize the screen?
Okay, sure. Yeah. Okay. Does it look better? Yeah,
much better. Thank you.
Okay, great. Okay. And let me talk about the VRM and VRM consortium. So the first background of the VRM consortium, it is found on 2019, and then it was created to aim to create new standards of the 3D avatar formats. We call it VRM. The format is more focused on the character expression as of anime or VTuber style of the character, rather than the realistic digital twins or humanoids. And then we're on the Tokyo based, and most of our company joining the VRM consortium is from Japan. Now, our vision is to be able to share the avatar across the multiverse, make the avatar portable and being able to own instead of being locked in the inside of proprietary metaverse. I think this is one of the visions that the most of you join in the MSF, this avatar working group. And our key contributors includes the VirtualCast and Pixiv, the most active contributors who have been working on the implementation of the VRM format, and also our reference implementation UVRM. But they also have a number of companies who are operating metaverse and the entertainment company. Those are our key contributors and the communities of the VRM consortium. I also have some observers such as Nintendo and NHK that we rarely talk, but they're there. And then we're very honored that we are now the liaison agreement with Khronos and actively working on to bring the VRM to be part of the GLTF extension. So our use case, so looking at the VRM use cases, we're mostly used on the games, entertainment, and metaverses. We have several implementation on the game engines, such as Unreal engines or Godots, which are reference implementation is for Unity. And now some of the DCC tools, such as Metasequoia, is starting to support the VRM formats, authoring experiences. So that's the great things. Also, one of our partners, the group Pixiv, is releasing the software called the VRM Hub, which you can register your VRM avatar format, and now it reaches the 3 million avatars registered. So I think it's a pretty big number that the VRM and these portable avatars has been used. Our model is the open source based, and then our code base is on the GitHub. It is GOTF based and working with Khronos now. And we've released the 1.0 in 2024, and then working beyond today. One of the key, so how our technology stack is built is that everything is on the GOTF 2.0, and then we are at an extension for the humanoid bone structures and secondary animations licenses, those stuff. And also the material extension to support the NPR material definition. NPR is the non-photorealistic expressions, more specialized for like anime-looking characters. And we call that the M-Toon. The technology's problem that we solved in VRM 1.0 is the amongst the default stance and the bone structure, local rotations. We also solved the problem such as like face animations that a lot of the character expressions, depending on the how the artists want to create the character expression, sometimes they use the blend shape, sometimes uses their bones, so that there is no one solution fits all. So we try to support multiple angles, and then we try to create a layer to abstract those expressions so that the application can virtualize those implementations. So and then the avatar creators can do what they want to do, how they want to express the character in the multiple applications that they bring the VRM to. We also released the new format called the VRM animation, which supports the animation data for the humanoid models. This is also defined as the GLTF extension, and then it supports it's built on top of the GLTF animation data, but it extends with the humanoid node mapping and emotion face gaze control mapping, so that those extensions in the VRM can have the animation data to play on top of the GLTF animation, so that it plays nicely with these avatars. Our current standard initiative is working on the secondary animations. This is our problem areas. So we have problem areas like interoperabilities and item customization, but our current focus is on the secondary animations. The secondary animations, basically the animations like claws or hairs, where that, like, the basic physical like body animations, and there's these things that moves depending on the when bodies, the hands or like faces moves. The biggest voices that we hear from the community is that the lack or poor expression capability of the secondary animation. So that's our main focus right now. And we are auditing from wide range of users and avatar creators what they wanted to do, or auditing from the proprietary metaverse users such as VRChat avatar creators, and how they want to do things, what they want to do things. And we're dividing up these implementation in the multi-step, so that we can extend, we can solve some of the problem by extending the VRM Springborn, or we're also working on
0317
implementing the claw simulation, so that we can tackle on these problems individually. And our criteria to implement these technology is that we make sure these technologies are easy to use, and also the multi-platform capable and VR ready. So our key challenges today
0317
is the biggest key challenges that we're feeling is that building an ecosystem, that how we can create and nurture the avatar ecosystem. And that one of the problem is that the successful metaverses or successful these entertainment platforms don't really need the standard as they want more specialized systems to keep their customers. And how could we turn them in so that we can have more platform uses these formats, and then we can have more better interoperability with the more bigger worlds, and also that we have the weak recognition outside of Asia. So we hope that the working with Khronos to standardize the format more will open up the more opportunity outside of Asia. The collaboration opportunities that we are sort of seeing is that obviously like building an ecosystem together, also the extending materials and expressions. That's not necessarily for the more like character, anime looking stuff. The VRM is not really closed actually for the VTuber like characters. I think the VRM itself should be able to work with the more photorealistic characters or expressions, and also that it is a very interesting opportunity that I see to work with the USD and MPEG for the interoperability. The thoughts on these avatar working group is that the problem is obviously too big. Some of you have mentioned that. I also agree that the problem is very big, and then how we can do things is that to just let's keep on our feet on the ground and just keep moving to start solving from where we can. So that's sort of what we are doing, and then we hope that we can work together to solve the actual problems, because that when we try to sort of capture the size of the problem, it's probably just too big for any of the organization. So that's our presentation. We still have like 2 minutes, but that's the end of the slides. So thank you.
Yeah, thank you, Hiroki. Yeah, thank you for sharing the updates on behalf of VRM. Let's give a cheers to Hiroki. And again, one request I got earlier was that the VRM team, they are more native Japanese speaker. So in case if anyone has more advanced question, please mention that in the chat so that they can work with the translator and build the response. So that would help them. Right. So now we're transitioning to the last speaker of the session. So we have Web3D Consortium. So we'll have Jody Williams representing Web3D Consortium, and he's a contributor at the Web3D Consortium. And here's a brief profile about Joe. Joe, yeah, please share your screen and you can start your presentation.
To begin with, just recognizing that we stand on the shoulders of giants, as they used to say. Some of them are gone, not with us anymore. Some of us are here, and some are yet to come. Because this idea of creating a standard for the very innovative and sometimes chaotic computer graphics is a long time chore with plenty of opportunities for people to contribute. I think where we want to contribute right now is this idea of a standards track humanoid or a standards track worker. Now, I think there's going to be a lot of cases where we will get in a situation where we have a standards track humanoid, that wants to be in an environment and he just might trade avatars at the door, and otherwise continue the standardized portion of the metaverse. But when I say it's a long trail, I mean that the trying to define a humanoid started a long time ago, and started from the idea of these mechanical armatures in stop motion. Computers come along and figure out how to do it. It takes a long time. The innovators of that time did maybe not necessarily want to share their secrets, but in the period of time going through there and working with graphics people, technical science, high-level simulation people, and performance people like sports, military, and so forth, we came upon the idea that, yeah, it should be a realistic skeleton. And we can get all the bones in there and joints, or we can leave them out. And when we talk to this thing, we want to talk about joint rotations. When we add skin to it, we want to talk about waiting for points of the skin, of the mesh. And so slowly this idea of what we can standardize came through and implemented in the HM spec 19774. Really took place in between 95 and here, but it was obvious at the time too that skeleton is a hierarchy of transformations that's easily implemented in any kind of authoring system, and that the geometry is geometry, and that the computations for the motion, either as a direct hierarchy or with a weighted by joint rotations, or some scalar driven ways to move points. And so anyway, this started to congeal in the SC24 JTC1. They're in their 38th round of this. Fantastic bunch of people from the entire world. And so between collaborations with IEEE way back when, W3C, we want to have a standardized format that's usable on the World Wide Web. Khronos, the core of the OpenGL, and OGC being the world, yeah, geography. Okay, and working with companies, schools, universities. The HM working group has evolved. Some of the people are here right now. Our two chairs, and the chair is what we have here, Mayong from is here. Look at that, and then William Life Graph. What's the name on that, William? I lost my glasses. Okay. Main idea is that we want to have a royalty-free royalty-free. I love this thing back. Okay. Royalty-free. The idea of X3D and the implementation of the otherwise platform-independent humanoid is that we want to generate some human-readable user code. This user code and data structures are, of course, going to end up down in, could end up down in GLTF. but we want to be able to talk to the user, to the composer in human readable form, and also have the common stuff that naturally reduces into GLTF forms, because that can really help in the delivery of it. The main idea, or one idea, is this is suspending your disbelief regarding the standards track. It's a difficult process. It's not just one company writing it and saying, here, it's the standard. It's an interaction with the whole world. Every country is commented on the ISO standards. What we're looking forward to is this idea of this inclusive, interoperable humanoid. This humanoid can go anywhere in the metaverse that recognizes him. It recognizes she recognizes the metaverse and what it can do in it. And the metaverse recognizes what is coming through here. So X3D is a convenient form to implement HANA, because it has all the standard features that you would expect for a humanoid with this kind of capability. It doesn't do everything. There are things that maybe we hoped had some proprietary interest from an organization would see fit to make it free and open in order to be implemented in the HANA stack. The skeleton here, maybe you saw that on many use cases. We totally support GLTF compatibility. In fact, HANA is completing up so that we can comment on the completeness and appropriateness of GLTF. And we want to continue to do that. The idea of what's ahead in challenges, users and implementations. We got to have an implementation that supports the style that we've got. Again, the common style that everyone agrees on is the very basics of animating. Users, we have a lot of users hidden in the straw. The idea that every big company has a very detailed set of people. Unfortunately, I don't think companies like Oracle, for example, Oracle and their enterprise solution, they're going to sit this user down in a nice couch and they're going to connect him up and they're going to display his business activities on a wall, and he'll be able to interact with that and move stuff from place to place and so forth, and run a business from the couch in virtual reality. A big application area that we've got going now, and frankly, I don't see any solutions out there, is this idea of fitting a garment, modeling this coveroid, having a correspondingly appropriate model for the humanoid, and really make that good enough so that the customer is able to do this virtual try-on and do an actual reliable buy on it, and thus cut the returns by, heck, if they're cut by 15%, it's a massive amount of material. Also, another thing opening up is this idea of developing these best practices for scanning, mapping, motion capture, and looking at, for example, that the MPEG showed the motion capture with 48 cameras and so on and so forth, and the accuracy of that, and how to make that into a realistic humanoid that somebody could grow up with and get old with, and be a database for their medical and familiar activities and so forth. A big opportunity there. Our chair William is very involved with that and looking at how to get agreement to document these different characteristics that a family may want to create an avatar for their child and have it grow up with them. And the idea that that child can be proud of it all the way along the way and cherish it and keep it up to date. The collaboration opportunities are wide open. There's several organizations. I mean, you can see a show every week where some group is putting forth a design for some sort of simulation that involves some sort of humanoid.
2 minutes.
Okay, we've got the working group. If one thing is, please look at the Interoperable Characters Avatars wiki. There's a couple of articles in there that deal with the humanoid. There's one that's kind of a notes for a X3D in a humanoid and just humanoid by itself in there that probably do a lot better, but there's some recording of that there in the notes for it. I think it's very instructive. I think anybody getting into the business or in the business should carefully examine the set of X3D standards and the H&M humanoid standard. H&M is adopted as a component in X3D, so there's full opportunity for support there.
1 minute.
Several implementations and that's it right there, isn't it? No. Well, Anita Havel is our executive director. Your participants are always welcome. You don't have to be a member to contribute on the X3D mailing list. And over the years, that's very instructive. Look at H&M, and anybody starting there would have a very good idea of the basic capabilities of a characteristic, realistic avatar. Thank you very much.
All right. Yeah, thank you, Joe, for your presentation. All right. Yeah, I didn't expect the sounds to come up. But yeah, so now we are at the end of our SDO roundtable. So now we will be transitioning to the Q&A section. So I'll share my screen just to give everyone a reference to the different SDO representatives who presented today. So in your questions, what we would like is your question, and are you referring to a certain representative or an SDO or a group of representative and SDO, or to everyone, right? So that way that specific representative can answer easily. So we'll open up for questions. Please use the Zoom's raise your hand feature, or you can mention the question in the chat. All right, we have Neil. Yeah, go for it, Neil.
Yeah, thanks. So first of all, big thanks to all the speakers. They all did awesome presentations. So, and I really appreciate everyone taking the time to be here today. I mean, it's really a question for everyone to try to tap into the collective wisdom we have around the table here today. Having listened to the different presentations, where do we see the opportunities? I mean, are there any clear first starting point opportunities for collaboration? I mean, maybe it came up kind of top of the list of everyone's list of challenges, which is the skeletons and animation systems. Should we catalog what everyone is doing? We've heard of 4 skeleton systems today. I'm sure there, of course, there are others too. Should we try to find commonality? or is that a fool's errand? Has anyone done that analysis that they would be willing to share? Really, yeah. Go
I've
ahead.
done some of. Sorry, Neil. I've done some of the analysis on skeletons and weighting systems, and it's more about setting a level of quality, because to MPEG standpoint, as well as Ken's standpoint, is that you're not going to have an answer for a universal avatar, and you're not going to be able to tell people how to rig or how to weight, but you can create a level set of like what a file handle for the weight system, or what a what are those levels of fidelity that can impact a use case, or why somebody would choose one file format over another file format, is something that I've seen be more applicable to the overall creativity of the market. If that makes sense.
Yeah, I mean, makes sense. Yeah. Any other views?
Yeah, I would view this problem as something as more of a remapping problem. Since it's been stated, I stated it earlier, and Katy also echoed it just now. Like, no one is ever going to get everyone in the industry to agree on a particular rig. So I think that an exercise in understanding what rigs are pervasive through the industry, if any are, would be useful. And then understanding how they then can map to one another may be a useful exercise, just if we want to understand how we can at least get some sort of interoperability going. But yes, agreed with most of Katy's points, if not all of them.
I mean, I would say that there needs to be more or less like a, I mean, what we do now obviously is pull the OBJ in and use like an auto rig when we're having to convert it to move it into more of a general creative environment. But if it's a specific use case, they might have a specific rig system, and so maybe there could be some level of interpolation between those rig systems down the line. But is it easier to just bring the OBJ in and then hit auto rig? If that's the case for more of a creative environment, is I think the big question to ask too.
Good. I see Joe raised your hand. Joe, do you want to add some comments?
Yeah. In order to help define capabilities or universalities or what's similar, it maybe help to start with a real firm foundation. That is, in HANM, every bit of that standard is based on the idea of transportable animations. It used to be maybe that the rigging was the most protected nugget of information down there that they didn't want anybody to see. And sure, the rigging is a lot of work. It takes, depending on whether you want a realistic skeleton, a robot skeleton, whether you want the arms to be moved independently, shoulders, or whether or not you want a nice realistic rig for the hips and feet and toes. But a base concept of let's create something that we can have a decent chance of making transportable animations. In other words, if I get to this one avatar, I can, if I get animations developed for this one avatar, that I can easily adapt them to my avatar. The only other thing is that who knows what AI is going to give us in this. But I think we've got a real important responsibility in this standards track process, at least to pass on to the AI what we think is our best design and see where it can go with it. Thanks. But transportable animations, a baseline for where to start this idea of where, because in this try-on process, we got to have a reliable way to look at, for example, proximity or contact or pressure between a garment and a humanoid. Thanks. That's it for that. Thank you.
Yeah, thank you. Yeah, great discussion. And yeah, just adding to that question, I think even the working group can help with curating the different skeletons that is available, right? For example, when we take Maya, we have advanced skeleton. Blender, we have Rigify and few other extensions. And then Epic Games in Unreal Engine, they have their own skeletons recommendation. And similarly, like VRM has their own skeleton recommendation. So it would be informational just to have that as a wiki in our working group, or there could also be opportunities for a roundtable in just focused on skeletons. So yeah, something we are happy to help on that front as well.
So do you want just open source skeletons, or what about proprietary skeletons?
I think for the informational or for the educational portion of our discussion, I think we would be open to include everyone, right?
Okay, because there's like the soft tissue ones and all that stuff that deal with some of that, but those are more proprietary.
Got it. Yeah, I think just for the starters, just getting those stakeholders and starting the conversation would be helpful. And from there, I think it may branch into more nuanced discussion based on the recommendations and preferences.
Mm-hmm.
Yeah, I think it makes sense to be inclusive, including the proprietary ones. Obviously, and if we end up with standardized solutions, wherever that happens, it'll be based on some of the more open formats, obviously. But if we're mapping out what the requirements are for the proprietary systems as well as the open systems to be able to map between each other, then we kind of need to know where those proprietary systems sit today. Yeah. It's an interesting question. I agree with all the comments. We need some kind of baseline as a baseline for extensibility and translation. So yeah, it's an interesting question though. How we create that? Is it a superset that we subset down? Is it a subset that people can extend? Interesting question.
Hi,
good question.
Yeah. Is there someone who voiced out? I think a person had a question.
Yes, this is Anita from Web3D Consortium. Based on the requirements you have today, I mean, I'm not sure if this group is gathering requirements. Is the standards registry group or any other group kind of mapping these features and seeing what's available in the open standards and proprietary standards? That could be our baseline, is to see what's available today, and then from there work on what are the gaps and what are the overlaps.
Yeah, I think not sure if Standards Register has done any work there, but definitely that is in the interest of this working group. There has been a previous presentation where there was comparisons made between VRM skeleton and Unreal Engine skeletons. But yeah, we are happy to continue that study further by including more skeleton variations.
Yeah. Well, and that would get into, do you want a subdivision of the weight relation? Because you can have the same skeleton, but your weight methodology may be different.
Yeah, I think in that subject, we need to talk about the skeletons and the weight painting, and how it drives animations, IKFK. I think, yeah, a lot of that related topics need to be discussed. But yeah, great discussion points. And any other, other than skeletons, any other topics of interest? I know like metadata is one point of interest. And I see Joe and Ken raising hand. Do you have any additional questions?
Go ahead, Ken.
Oh, I was just going to write down my question because I didn't want to jump in line before the metadata one, which I believe has been in the queue for quite some time. Let me just write it down.
Okay. Yeah. Joe and Don, yeah.
Can I share for just a quick second here? Or Don, just a second, it doesn't matter, but let me just share this for 1 second.
Yeah, sure. I put it in the chat that metadata can, independently of the file format, help control whether somebody has access or appropriate use. And there are two groups that were maybe mentioned in passing today, but two MSF groups I think are important for this. Metaverse Standards Registry. It's considering the possibility of calibrating all the many use cases with the common vocabulary, the common ontology in the Metaverse Standards Register to see if we're speaking coherently. The other group that adds value in this domain, at least for X3D, is the 3D Web Interoperability Group. We hope to steadily show capability in that portal, or however you call it, way to access a metaverse.
Yes.
Accessibility working group is going to have some important contributions. Excuse me, Katy. One thing I just wanted to add in here is that this working group, the continuation of it, at least on the graph I saw, what we want to do is examine these hierarchies, possible hierarchies in the skeleton, or new ways to animate a skin or surface without a skeleton maybe. We want to, the working group objective is to look at this material, the materials, and geometry, animation, onboard, streamed in, out, innovated on the spot, and look at interaction, sensors, actuators, viewpoints, whatever else is necessary to create this interactive humanoid. Thank you. And as Don mentioned, the other working groups in here are really important. Like I say, I think this accessibility working group is going to play an important point through here. This idea of being inclusive, fully inclusive as possible. So thanks.
Yeah, thank you, Joey. It's a good list. I took note of it. So definitely we will include that in our exploration with the components.
Sure.
All right. Any other questions?
This is Carol. I haven't been able to raise my hand. I have no raise of hand. Can you guys hear me?
Yes.
Yes. So I think actually one of a good test of all of these would be if people can actually age your rig. And that's one of the things that we found was that everybody tends to have the body stand very upright. Can you age your rig to be 60 to 95? Can you actually have it in the metadata, for example, that says, hey, this is the whole body, or this is only the hands and the face, or the hands and the face? How are you looking to actually get the clothing to act act appropriately? So I think there's like some basic things that would be really helpful for the interaction. Even the simple thing of hey, can you actually identify whether your right-hand rule, left-hand rule, because if your data comes in just as text, it's not that easy to figure it out, right? It's not like I'm getting an OBJ and I can actually see it. So one of the things is, how can you actually make it so things can be automated, can be reviewed, can be looked at very simply to know whether I want to be able to use your avatar or not, right? If I get an avatar and right in there in the metadata it says head only and hands, I'm not going to use it to have garments, right? So how can you make it such that it's very easy for people to be able to read the files ahead of time before they have to use them? So that's my thoughts.
Yeah, and that deals with the rig structure. That's not so much the blend shape, because we tried kind of both of those avenues, which is where there are privatized rig systems that do allow for some of that, where just, you know, the artist working with the position or the scan capture can be a baseline for it. But we've seen that if mathematics is a core essential part of it, that you want to have a rig and weight system that works with it, which again gets into the weeds of the different types of rig and weight systems and why you would have them. But yes, we replicated Carol's grandpa, or Carol's dad, as we endearingly call him Gramps. And it was a big challenge, actually.
Yeah, so they replicated my dad when he was like about 95. He's since passed, but one of the things that was definitely a challenge was how to actually be able to show that the body can change from being, you know, straight up and down to actually bending over, bending the knees, walking a slightly different way. How to actually bring that in such that it is merely the animation that is to be able to do that. I'm not getting a hunched over body. I'm actually trying to roll the shoulders. I'm actually trying to adjust. And so what I'm seeing is there's kind of two sets of animations. One is I'm just an avatar, or I'm an avatar that's only the head and the hands, the face and the hands. But then I have an avatar that's a whole body. Then I have an avatar or humanoid that's within the whole body, that is the whole body, that needs to be in the complete scene, that needs to be able to show how a body ages, what that does. And I need to be able to control it from just the skeleton and the rig. And how do I have enough rigs in there to be able to fully map the upper body and to fully map the neck and to show all that? And so there's all these subtleties that I think it'd be really good to be able to know at the beginning, oh, this is what you did, and how do we actually put that in metadata so that you can tell what your file consists of.
And that does actually deal with apparel, because most of our dress forms are built for people under the age of 35, which does not, it's kind of why we had to create more of an apparel rig system, because we test it differently, we use it differently, we have to be able to move our joints differently than other models allow for, so that we can actually age a person, because when a person ages, the pattern related to the body and the making and crafting of clothing for reality actually is dependent on that. And if we're going to do that in a metaverse setting, even in an educational metaverse setting in the future, we need to be able to pull those things in and out and teach students how to do digital fit criteria within a reality-based mechanism.
And Nick also has his hand up. Nick, do you want to add something?
Yeah, I just wanted to jump in briefly and point out that when we're talking about avatars and the history of avatars to date, we're talking about somewhat superficial aspects of the characters that we're showing. We talk about the skin and we talk about the skeleton, but the skeleton isn't a biologically kinematically motivated skeleton. It's designed around the idea of deforming the skin efficiently in order to achieve, the superficiality of moving the vertices into the right place. In order to really do a good job on things like showing the effects of aging, it's hard to imagine how you can get there strictly on the basis of like visual morphs as opposed to an underlying biokinetic model. That would actually have the information that you need to really understand, like, why do the shoulders roll over and things like that, as opposed to just scanning a whole bunch, which would ignore like the actual reality of the person's interior experience that's leading to their actual pose. So I feel like another level of avatars is really required for so many applications that is biologically motivated.
Well, and I see that we will have a future of gamers that are, 70, 80, 90 years old, because that's our generation of people that are existing today, even where we grew up on video games. So I don't think that it's far off the mark, but they also like to be able to share information, or even if it's a synthetic body that's being used for BMI tracking, or for like them going to the gym and getting like somebody to scan them, and they use a synthetic. At least the synthetic can have the posturing, and then they can track their posturing. And this is something that LifeGrapher, William, likes to do within his ideology of avatar use. So
yeah, and another aspect also is even within the realm of avatars that we've got today, we've talked about the fact that historically these skins have been rotationally based, and I believe VRM and other more recent formulations also includes prismatic joints, which are really necessary. So I think there's a lot of work to be done just to get to where we should be these days.
Okay, we have 1 and 20 seconds left.
Yeah, probably a time for one more question. Who wants to take the last question?
Well, I could, I've been working through the chat. It's quite interesting. A theme that's come up 2 or 3 times. Could we have shared models to work with? I think that might be an interesting product of the working group, because we don't have to go all the way to a Morgan, call it a reference standard. Let's start with something simple but functional that lets us practice the different things we're trying to do. That might be useful.
Noted. Yeah, it's a good point. We had something like test bed in our pipeline. The idea of test bed is having a 3D sim environment where anyone can deploy their solutions and test it. And then it's also a good idea that we can provide sample assets that people can use to test their standards. So yeah, so we'll work on it. Thank you. All right, so I think then we are at the end of Q&A timer. So thank you again to all the speakers for coming over on a short notice and then trying to do this full presentation. So really appreciate all the work you have done and sharing all the updates to us. And thanks to all the participants who came today. So we encourage everyone to keep coming to our working group meetings. It happens bi-weekly at the same time. So just this meeting has been increased to 2 hours. Usually it's a 1 hour time slot of session. And we do have a mix of general working group discussion and education session discussion. So highly recommend being part of it. And yeah, let's give one final cheers to all the speakers.